Okay, in this lecture, we're going to finish up our Matlab basics by discussing character strings and structure arrays. So we want to create text strings in Matlab. We want to combine existing text strings. We want to write expressions using special functions to modify character strings. We want to create cell arrays, and we want to perform basic operations on cell arrays. So character strings store alphabetic or alphanumeric data. They're similar to vectors where each character is a separate element. You use our assignment equal sign operator to place the desired text in single quotes. So for example, if I wanted to store the words American bison in a variable TS1, I would type in TS1 equals single quote American bison single quote colon. You can also do it with numbers. For example, TS3 is equal to single quote 42 single quote. To place an apostrophe within a text string, you actually have to hit 2 single quotes because MATLAB's going to think a single quote is ending your text string. So you just have to hit it twice. It's a little nuance of the program. You can combine text strings just like you would combine vectors by concatenating them. So if I have a variable, say Willie's, and I have a variable 2 that says brain, I can create one that says Willie's weird brain by typing TS, my text string, is equal to open bracket W1, comma, and then I'm going to create a new word, which is weird. I'm actually going to put a space between my apostrophes and the word weird, comma, W2, so that would contain Willie's weird brain. You can use indexing to create or modify character strings. So if I have word 1 and my text string is, if I say word 1 is equal to text string of 1:7, word 1 is only going to contain Willie's. Note that even though we have to hit the single quote sign twice to get an apostrophe, it only counts as one character. So if I say word 2 is equal to TS of length of TS minus 3 to length of TS, I'm going to get the word rain. If I wanted to remove the word weird from my text string, I can say TS of 9, 14 equals square brackets, and that will remove the 9th through 14th character, and you would be left with Willie's brain. Indexing works very similar to the way that it worked with vectors. So if I have E is equal to ABCD and I say E of 2 to 4, I'm going to get BCD. If I say F is equal to dog, F of 2 is going to be O, F of 2 to 3 is going to be OG. Some functions that work with character strings. The function blanks creates a string of blanks compared to the 0 function for matrices. Is a letter finds alphabetic characters in a string. Is space finds spaces in a string. str find finds a string within another string. Str rep replaces the substring within a string. We can compare two strings. We can compare two strings ignoring case. This is very useful because comparing two strings is case sensitive. If I want to do it in an in case sensitive way, I have to put an I on it. You can convert a string to lowercase, you can convert a string to uppercase, you can convert a number to a string, and you can also convert a string to a number. The last one is very useful if you want to do some calculations on character strings, because without it, you're actually going to get numeric results because each character is stored in a numerical format. So what is a cell array? So far we've had variables either be all numeric or all alphabetic. We haven't had a mixture. Cell arrays actually store both numeric and non-numeric values in a single variable. So you can combine your numeric scalars, vectors, and matrices with character arrays. It's useful in your communication with Excel. Each element in a cell array contains another MATLAB data structure. So your cell array can contain a cell array, a vector, a scalar, a matrix, or a character array. It can be a numeric matrix, a text string, or other cell arrays. So how do we define a cell array? So when we define a vector, we used our square brackets. When we define a character array, we use a single quote. To define a cell array, we're going to use the curly brackets, curly braces. So if I have the word test in a variable TS, Matlab's command window is going to display TS equals test. If I define a variable that is CB right equals curly braces and then the word inside of it, the text that's going to display is actually in quotes, because it's going to tell you what kind of data is in that cell array. And over here I have a character that I said CB both of 1 equals test. Here, see how it says test, and then CB right, it says CB right is a 1x1 cell array, and this is the data that's in it. If I want to figure out what's in it, you have to extract the data a certain way. Because if I just hit CB both, it's going to tell me I have a 1x1 cell array and not any of the information that is in it. So how do I combine data? So if I have B is equal to this matrix and D is equal to this matrix, so I combine data using square brackets, the identities of the original matrices are lost and they become part of a larger matrix. If I do the same thing with a character string, I have the variable f and I have the variable g, rat. If I say h is g comma f, h is rat dog, and h of 2 is a. Again, my original variables are lost, the original information is lost. We have no easy way to extract rat and dog from the variable h, because the variable h is now rat dog. Well, how do we fix that? Why do we care about that? Well, that's where structure arrays come in. Because if I combine them using curly braces instead of square brackets, the identities of the original strings are maintained as individual elements. So if I take the same example where I have f is dog and g is rat, and I create a variable j and I say j is curly braces g comma f, j actually contains rat and contains dog. So j of 2 is dog, not a, because it contains their original information. So it makes extracting things easier. It's a way to store more information, but also be able to extract that information without losing its original identity. So our cell arrays can store different variable types in any combination. Sorry, it's a cell array, not a structure array. So if I have b is equal to the vector 1, 2, 3, f is equal to the word dog, g is equal to the word rat, m I can define as curly bracket f comma b. So I'm creating a cell array m, and m would then contain the character string dog and then the vector 1, 2, 3. If I created a different cell array called n and I said n is m comma g, n is actually going to contain the 1x2 cell array of m and then the character string rat. So cell arrays are actually very useful, especially with keeping text and data together and then being able to extract it. So how do you extract data from a cell array? So like I said, it's great for storage and we can extract stuff from it, but how do we do this? So when you use the parentheses to extract data from a cell array, you get a cell array. So if I was to say CA6 is a 1x3 cell array that contains the scalar 777, a 2x3 cell array, and the word apricot, and I say CA6 of 1, it's going to tell me that I have a 1x1 cell array, and what's contained in that cell array is the value 777. If I want the value 777 to extract the contents from the cell array and not have it be a cell array, I have to use the curly brackets again. So curly brackets create a cell array and also remove information from a cell array. So if I was to say CA6 of 1 in curly braces, I'm going to get my scalar value back of 777. So this is something very important to understand, the use of curly brackets with cell arrays. So let's look at extracting data in another example. So I have my variable b, my variable f, and my variable p, where b is a vector, f is a character string, and p is a cell array. So p is equal to the character string dog and then the vector 579. If I say a is equal to p of 2, a is going to contain that entire vector 5, 7, and 9. If I say c is equal to a of 2, 3, I'm going to get c is equal to 7, 9, as we would expect from our previous knowledge. If I say s is equal to p of 2, and then in parentheses 2 to 3, I'm actually going to get s is equal to 7, 9. So using this syntax, where first we extract something from our cell array, and then we extract something from our extracted information, is a shortcut to combining two lines of code. So first we extract the information from the cell array using curly braces, and then we extract information from that data using our parentheses like we were previously used to. It allows us to combine these two lines of code. So what are some functions used with cell arrays? We have isCell determines if a variable is a cell array. Cell creates a cell array filled with empty matrices. Num to cell converts numeric matrix into a cell array. Mat to cell splits a matrix into sub-matrices and stores them in a subarray. Cell display displays the contents of a cell array in a window. And cell function applies a function to a cell array. So let's look at another example. Here we have the following cell array stored in Matlab. We have person equals curly bracket Skywalker, comma Luke, curly bracket, comma the word Jedi, then comma 31, then comma the vector 5 and 10. So inside this we have inside of the cell array, we have a cell array in the first position, we have a character string in the second, we have a scalar in the third, and we have a vector in the fourth. So we want to know what type of variable x will be if we use this following expression. So if I say x is equal person, curly brackets of 1, what is it going to do? Well, it's going to extract the information from the cell array that's in position 1, which in this case happens to be a cell array. So our answer is C. If I had done a 2, it would have extracted a text string. For this example, we want to figure out what is going to be stored in our cell array if we have variable flavors equal to the cell array that contains chocolate, vanilla, and strawberry as character strings. So we want to write a code segment to create a menu. What are we going to do? So first, we're going to say our choice, which is a variable that we're defining, is equal to menu. Menu is a function that creates a pop-up menu in Matlab. And then it's going to say choose your favorite ice cream flavor, which is just some text to be displayed in the menu. And then comma flavors. We're going to feed in our character string. So what it's actually going to display is this little nice pop-up menu that allows somebody to choose what their favorite ice cream flavor is. It's a very useful way of using cell arrays. So let's look at another example. We're back to our person being defined as a cell array that contains 4 components that have to deal with Star Wars. So this time we're trying to figure out what's going to be stored in variable x if we type in the command person, curly brackets 1, comma 2. So let's work on this from left to right. First, it's going to extract entry 1 from our cell array, which is the cell array of Skywalker and Luke. And then we put in parentheses 2. And what is it going to do? Well, going to extract the second part of our first cell, which is a cell array, but since we put it in parentheses and not in curly brackets, we're still in a cell array. If you wanted to get the text of Luke out, you would have to put that 2 in curly braces as well. So that's really it for cell arrays. Cell arrays are basically storing everything that we've learned about previously. It allows you to store our character strings, our vectors, our matrices all in one convenient place. You have to be careful with extracting informations and your use of curly brackets. We learned about character arrays, which are text strings. You have to be very careful when you're doing calculations with character strings, because each letter in Matlab is actually stored as a numerical value based on a standard code system. That's where the functions string to num and num to string come in handy, because they will convert the numerical value to the alphabetic value. In our next lecture, we are going to move on to functions in Matlab, like creating your own user-defined function to be used in calculations.